Alright, so today I'm going to borrow somebody else's video. I am going to pause the video as we go and hopefully, excuse me, you can write down the things that I need you to write down as we go. Okay, we're going to start out with the objective for today's video.
Today's lesson is about law of exponents. It's Common Core 8th grade standard EE.1.
So write that down, laws of exponents, Common Core standard E8, EE1. You will be learning how to use exponents. That is your objective today, learning how to use exponents. Here we go.
Let's first talk about what is an exponent. Well, it tells how many times the base is used as a factor. So, for instance, if I give you something like b to the n, well, b is your base and n is the exponent.
Go ahead and copy this down, and then push pause while you're copying it down, and then push play when you have finished writing the entire thing down in your notes. So make sure you get that the b is your base and that n is the exponent. Push play when you're ready to continue.
So whatever that number n is going to be, it's how many times we multiply the base together. So 0 as an exponent is another important concept. So if I give you anything to the 0, it really doesn't even matter what the base is. Anything raised to the 0 will give you an answer of 1. So for instance, if I give you 6 to the 0, just like any other base to the 0, the answer is always 1. A second important rule is negative exponents. So if I give you a base a raised to a negative exponent, how do you fix it? Well, you cross the fraction bar. So if it's a negative exponent in the numerator, like a to the negative n, it becomes a positive exponent in the denominator. So let me give you an example. 2 to the negative fourth. I want to solve this. Well, with the negative exponent, I just can't. How do I fix it so I can solve it?
Go ahead and copy this down. Make sure you have the heading negative exponents for every non-zero a. A to the negative n is equal to 1 over a to the n. When he talks about crossing the fraction bar, he talks about creating a fraction, using a fraction bar, and bringing the expression down. Make sure you're including a 1 if you don't have any a coefficient to that number. Keep listening.
Well, if it's a negative 4 exponent in the numerator, we cross the fraction bar. We take it to the denominator. And now 2 to the fourth, if I want to simplify that, then I know the answer is 16. So 2 to the negative fourth, same thing as 1/16. Another example would be like 5x to the negative third. Now here's the thing to notice about this one. X is raised to the negative third, but 5 is not. 5 has actually got a power of 1. It's positive already, so we leave 5 in the numerator. We do not mess with it. But x to the negative third, we cross the fraction bar to get that positive exponent. So our final answer is 5 divided by x cubed. Now a third example would be 2x raised to the negative third. Now notice what's different about this one. 2x is all in parentheses, which means all of 2x is raised to that negative third exponent. So to fix this one, to get rid of the negative exponent, we would cross the fraction bar with all of 2x. So the answer becomes 1 divided by all of 2x cubed. A third rule is multiplying powers with the same base.
Make sure you copy this down now. Multiply powers with the same base for every non-zero a and real numbers m and n. And then copy down the example. That says a to the m times that little asterisk sign. This one here is actually saying multiplication. Make sure you have this written down. When you're done, push pause. Make sure you're pausing as you're going along so you keep up with him, and write down the things that you need to.
So as long as you have the same base, the base does not change, and you add the exponents. You add the powers. So let me give you a for instance. If I give you 3 squared times 3 to the fourth, how do you simplify this? Well, both of them have a base of 3. If they both have a base of 3, then that means I can add the exponents. And 2 plus 4 is the same thing as 3 to the 6th. Now, if you want to simplify that further, you can, because you can find 3 to the 6th but we're just talking about right now how to combine the exponents. Let's look at a second example. Now this time I don't even know what the base is. It's some unknown x. So we have x cubed times x to the 7th. Well, the great thing about this rule is it doesn't matter what the base is, whether it be a number or whether it be a variable. If they have the same base, and in this case they're both x, we still can combine the exponents. And 3 plus 7 will give us x to the 10th. One final example of this would be like the quantity 3x raised to the 4th times the quantity 3x raised to the 1st. So if there's no exponent written, it's understood to be a power of 1. So we'd do 4 plus 1, which would mean our final answer would be 3x raised to the 5th. Now let's talk about the rule a power to a power. What do I mean by that?
Okay, here we go. Copy this down, raising a power to a power. Pay close attention to this here. We're about halfway through his video, and I am going to pause it along the way. I want you to pause it too and make sure you're writing down everything that you need to. Push play when you're ready to go.
What I mean is I have only one base, but multiple powers. Well, when this happens, what you do is you actually multiply the powers. So let's try a problem. So we have 5 cubed squared. Now 5 is the only base that I have, but I have more than one exponent. So what do I do with the 3 and the 2? I multiply them together. So this becomes 5 to the 6th. A second example would be like x to the 4th to the 5th. Again, only one base, only x as a base. What do I do with the 4 and the 5? Well, I multiply them because it's a power to a power. So this becomes x to the 20th. One final example of power to a power is 10 to the 7th cubed. Again, one base, more than one exponent, you multiply the exponents. So this becomes 10 to the 21st. Now let's talk about a product inside of a power. So what I mean by that is we're going to have more than one base multiplied together inside of an exponent.
Go ahead and copy this down. Make sure you're pushing pause and getting this all written down. Push pause now, and when you're ready to continue, push play.
So what we do with that exponent, that n in this case, is we must distribute it. So an example of this would be 2y squared all raised to the 5th. So 2 is understood to have an exponent of 1 and y squared. What do I do with it? Well, this is really a power of a power. So anytime you have a base with more than one power, you must multiply them. So we got to distribute that 5. We get 2 raised to the 1 times 5 and y raised to the 2 times 5. Well, if I actually multiply those exponents, I'm going to get an answer of 2 to the 5th, y to the 10th. A second example of this would be x to the negative 1st times y to the 4th, and again, all of that product is squared. So I've got to distribute the square when this happens. So that's going to give me a x to the negative 1 times 2 and a y to the 4 times 2. Well, negative 1 times 2 is negative 2, and we've got to fix negative exponents as well because that's a rule that we talked about earlier. So that means that x squared has got to go to the denominator so we can make that exponent positive. And then with the y, the 4 times 2, well, it's 8. It's already positive, so we leave it in the numerator, and the answer is y to the 8th divided by x squared. A final example of product to a power would be like 3 squared x cubed, and it's all raised to the 4th. Again, we've got to distribute that 4. But when we distribute that 4, we got power to a power. So we're going to have 3 raised to the 2 times 4 because more than one power, we multiply the exponents. And then x raised to the 3 times 4. Well, if we simplify that, the final answer is 3 to the 8th times x to the 12th. The final rule that we're going to discuss with exponents is dividing powers with the same base. So anytime you have the same base,
Giving you some time to pause here. I know he goes really quick, so I even have trouble keeping up with him. So make sure you're writing this down and pushing pause.
something in the numerator, something in the denominator, how do you simplify it? Well, you do the numerator exponent minus the denominator exponent. So the one on top minus the one on bottom. So an example of that would be 5 to the 9th divided by 5 to the 7th. Well, both of the bases are 5, so we can combine this. We can simplify it, and we do the numerator exponent, which is 9, minus the denominator exponent, which is 7. So we do top exponent minus bottom exponent. So that becomes 5 squared, which is 25. A second example would be like 7 to the 6th divided by 7 to the 8th. Well, again, top minus bottom, so it's 6 minus 8. Because they have the same bases, I can combine them, and that's going to give me 7 to the negative 2nd. We cannot have negative exponents, so we cross back over the fraction bar, and it becomes 1 over 7 squared, which you could also write as 1/49. A third example of this would be z to the 14th divided by z cubed. So again, top minus bottom with exponents whenever the bases are the same, and in this case, they're both z. So it would be z raised to the 14 minus 3, which is z to the 11th. So these are the basic rules about exponents that we must know in order to be successful in algebra.
Okay, so hopefully that was helpful. I know it was a lot of information, but remember, you don't have to do any work at home when you come to class tomorrow. I'll answer whatever questions you have. If something really stood out as something that you didn't understand, go ahead and highlight it in your notebook and ask me tomorrow, okay? Have a great one, and I will see you tomorrow.